Okay, now we're going to use an example of a real-world convection cell, and this is called a Hadley cell. We often use this as an example because it's the most well-characterized cell that we know of. So, same basic principles. We have sunlight, radiation coming in that's able to heat up the Earth. As the Earth gets hotter, it releases heat into the atmosphere, and it's able to heat up this lowest layer of air via conduction. And remember, same principle, as the air gets hotter, it starts to rise, and then it hits a certain point in the atmosphere and it starts to cool off. And then when we have colder air, that's going to sink down and really drive this cycle or cell movement. And so we finish off by, again, that air that has sunk is going to start to be heated up again by the Earth's heat and then rise. So it'll do this pattern over and over again. When we're talking about the Hadley cell, we're actually talking about a very specific geographical location. So we're talking about the start of the cycle being around the equator, so 0 degrees, and then the sinking of the air being around 30 degrees. And so this is what's really interesting. It's this convection cycle that's causing there to be these regional climate differences. So think about at the equator. It's really intense, the sunlight coming in. Well, this causes a few things. A, the Earth to be warmed up, but also we have a lot of evaporation of water. Thinking about your pot of water when you start to boil it, when that water becomes really hot and boiling, you can see the steam coming off, and that's actually water that's evaporating into the air. So the same thing is happening around the equator. You have a lot of heat coming in, evaporation of water, and that's why the air is really humid in these rainforests and such. And then as that hot air is rising, it cools off, and actually colder air is able to hold less water than hot air. This is just a basic chemistry principle. So once that air starts to cool off, it has to release all that humidity, all the wetness in the water, and it does that by rain, so lots of rain. So that's why in the rainforest you have humid air, but then also you get a lot of rain, because as soon as it starts to cool up in the atmosphere, it has to release all of that humidity. So then we have the cold air travels up north, so it travels to about 30 degrees north, and then it starts to cool off, and then it starts to sink around 30 degrees. And if you think about it, over here in this tropical zone, it lost all of its humidity, all of it, the rain over here. And so by the time it gets to about 30 degrees, it's very dry air. So then you can think about when this dry air sinks down, that's going to lead to these desert conditions, or very dry conditions around 30 degrees north and south. So we have things like the Sahara Desert at that location. And it's all because of this Hadley cell, aka convection cell, where here around the equator, you have a lot of evaporation, you have very humid air, and then as soon as it cools to a certain point, it has to release that wetness in the form of rain. And then you have it traveling up north or south to about 30 degrees, and that cold air starts to sink. And it's these changes that lead to these very different climate regions. So tropics at equator versus deserts at 30 degrees. So it's really, really interesting. So if you think about it in terms of the enhanced greenhouse effect and what impact that has on this convection cell, you can think of it as, remember, the enhanced greenhouse effect is that more heat is being released from the Earth because there's more heat being reflected down into it from this layer of greenhouse gases. So if you have more heat coming off the Earth, you're going to have more evaporation. So you'll have more humidity, and that will lead to more rain. And so if you have more rain here, you're going to have even less available in these drier zones. So that's why other zones, and other important factors as well, but other zones will be having longer periods of drought or even drier conditions. And so this is, like I said, the best example we have of a cell, and it's been pretty worked out well. And there are other cells around the Earth, but these are very complex because there are a lot of other compounding factors that also impact those climate systems. And so that's why you really have to think of climate change and global warming as a regional issue, is because of things like these cells. Like, we're not having the same impact at the equator as you see at 30 degrees. And that's because of these kinds of cells. So really important to know the basics of these things, and that we can't really generalize about global warming and its impacts on every single location.